Shocking! That's the word everyone's been using to describe the recent discovery made by the James Webb Space Telescope. It was only just launched last year, and it's already managed to make a discovery that has rocked the entire space industry. No one was expecting this, least of all the team who built the telescope. But that's the great thing about space, you never really know what you'll find. This discovery has left scientists baffled and has forced them to rethink everything they thought they knew about the universe. So watch the video to the very end to find out what shocking thing they have discovered. The James Webb Space Telescope has revealed the atmosphere of a far-off exoplanet called WASP 96b. This planet is about 700 light-years away from Earth and is about twice the size of Jupiter. WASP 96b is what's known as a hot Jupiter because it's very close to its star and has a very high temperature. In fact, the temperature on this planet is so high that it's actually hotter than some stars. The atmosphere of WASP 96b is full of steam because it's close to its star. This makes it very difficult to see the planet's surface. However, the James Webb Space Telescope was able to peer through the steam and reveal the planet's atmosphere. The James Webb Space Telescope, JWST, also discovered indications of clouds and haze on the exoplanet WASP 96b. The faint change in the brightness of specific colors of light can be used to detect the presence of gas molecules. This is the first time that clouds have been observed on an exoplanet with this level of detail. The Hubble Space Telescope has been studying the atmospheres of many exoplanets over the past 20 years. And in 2013, it made a groundbreaking discovery. It detected water on a planet for the first time. This discovery was a major step forward in our understanding of these far-off worlds, and it has led to many more discoveries about the nature of exoplanets. However, the Webb telescope, which was designed to search for distant planets, made the observation using its powerful infrared vision. There are more than 5,000 confirmed exoplanets in the Milky Way, and that number is only going to continue to grow as we learn more about the universe. And WASP 96b is one of them. WASP 69 is an unusual type of gas giant that doesn't have a counterpart in our solar system. It's about 1,150 light-years away and is one of the largest planets ever discovered. This planet is so big that it's about the same size as Jupiter and Saturn combined. WASP 69 is also very hot, with a surface temperature of about 1,000 degrees Fahrenheit. WASP 96b is a large, gaseous planet that orbits close to its star, making it the perfect target for atmospheric observations. Its large size and quick orbital period make it ideal for studying the atmosphere of a planet outside our solar system. Additionally, its atmosphere is quite puffy, which makes it easier to observe than other exoplanets. The Near-Infrared Imager and Spectrograph, NIRS, on the Infrared Telescope Facility, IRTF, observed WASP 96 for 6.4 hours as the planet moved across the face of the star on June 21st. The data revealed that WASP 96b is a very hot Jupiter with a dayside temperature of about 2,500 K. This is the first time that the NIRS has been used to study a transiting exoplanet. The end result is a light curve that provides information about the planet's atmosphere. The data suggests that the planet has a cloudy atmosphere with scattered clouds. The light curve also shows that the planet's atmosphere is hazy, with the haze extending from the planet's surface to high altitudes. According to recent observations, the WASP 96 exoplanet has a clear signature of water, which means that it could potentially support life. This is based on the fact that the planet has a haze and clouds, which were believed not to exist based on earlier observations. When scientists first observed WASP 96b, they were baffled by its transmission spectrum. It was like nothing they had ever seen before. The spectrum showed absorption features that were much wider than anything else that had been observed. For the first time, scientists have been able to identify and quantify the abundance of important gases in the atmosphere of a distant exoplanet. This is a big deal because it means we can now study the atmospheres of exoplanets in greater detail than ever before. The study was conducted by observing the light of an exoplanet called WASP 96b as it passed in front of its host star. By analyzing the star's light, the team was able to identify the gases present in the exoplanet's atmosphere and quantify their abundance. This is a huge step forward in our ability to study exoplanets, and it will help us to better understand the formation and evolution of planetary systems. Atoms and molecules have distinct patterns of absorption and emission at different wavelengths. However, they also absorb and emit light in a very similar way to how people distinguish between different fingertips and DNA sequences. Scientists have used the near-infrared spectrograph, NIRS, to obtain the most accurate near-infrared transmission spectrum of an exoplanet atmosphere to date. This transmission spectrum can tell us a lot about the atmosphere of WASP 96b. For example, it can help us to understand the distribution of different atmospheric gases and how they interact with each other. It can also give us clues about the planet's climate and weather patterns. Now, when it comes to weird and wonderful spectrums, it doesn't get much better than the WASP 69 spectrum. This amazing spectrum spans a huge range of wavelengths, from the longest in the infrared all the way down to the shortest in the ultraviolet. Not only that, but it also includes all the colors of visible light, from red to violet. So what causes this weird and wonderful spectrum? It's actually caused by a type of star called a white dwarf. These incredibly dense stars are the leftovers of larger stars that have burned through all their fuel. As they cool down, they start to emit light at all different wavelengths, including the colors of visible light. We all know that water is vital to life as we know it, but did you know that there are other molecules like oxygen, methane, and ammonia that are also essential for life? These molecules are not immediately apparent in the WASP 96 spectrum, but they should be detectable on other planets. Webb will have the ability to measure the amount of water vapor in the atmosphere by using the spectrum it observes. Researchers believe that this will be a valuable tool in understanding the climate of a planet and determining the habitability of a planet. New research will soon allow scientists to measure the amount of water vapor on WASP 96b. This data will give researchers new insight into the planet's climate and could help them draw conclusions about its habitability. The James Webb Space Telescope, JWST, is a powerful tool that has allowed scientists to make groundbreaking discoveries about the universe. The telescope has provided astronomers with unprecedented images of the universe and was able to capture the image with such clarity and detail due to its powerful infrared capabilities. The James Webb Space Telescope's primary mirror is made up of 18 hexagonal gold-plated beryllium segments that work together as one unit. The JWST's mirror is huge. It's 27 feet in diameter and weighs over 2,000 pounds. But it's not just the size that makes this mirror special. It's also the fact that it's designed to capture infrared light. Infrared light is invisible to the human eye, but it's important for astronomy because it can help us study objects that are too far away or too faint to be seen in visible light. The JWST's mirror is specially designed to capture as much infrared light as possible so that we can learn more about the universe and how it works. Scientists have used other telescopes to study the atmospheres of exoplanets in the past, but none of them have been able to provide the level of detail that the James Webb Space Telescope will be able to. According to Colin, an expert on exoplanets, Webb's extreme stability and its orbital location make it an ideal candidate for hosting life. Colin goes on to say that Webb's unique characteristics make it a perfect target for future study. NIRS is going to be a huge help in the exoplanet research community. We are only beginning to scratch the surface of what this new telescope can do. The detail in the spectrum is unlike anything we have ever seen before. It's going to help us answer some big questions about how planets form and what they are made of. Dozens of researchers will soon be using a new spectrograph to examine the atmospheres of dozens of exoplanets, ranging in size from small rocky planets to giant gas planets. The spectrograph is a powerful tool that will allow scientists to study the chemistry of exoplanet atmospheres in unprecedented detail. This new spectrograph is just the latest in a series of powerful telescopes and instruments that astronomers are using to study exoplanets. With each new generation of telescopes and instruments, we are learning more and more about these fascinating worlds that exist beyond our solar system. Exoplanet research is one of the most important science goals for the JWST, and it is expected to take up a significant portion of the telescope's time. In fact, in one observation cycle, the JWST will spend almost a quarter of its time observing exoplanets and the material around them. Antonella Noda, a scientist, says that in the future, most science will be conducted using spectra. Spectra are patterns of light that are emitted by an object. By studying the spectra of an object, scientists can learn a lot about that object, including its composition, temperature, and movement. Noda says that spectra will be used to study all sorts of things in the future, from the atmospheres of planets to the composition of stars. She believes that spectra will help us to understand the universe in ways that we never thought possible. And there you have it. We hope you found this video interesting and informative. And if you have any questions or comments, we'd love to hear from you. Thanks for watching, and we'll see you in the next video.